Let's talk about scores based method in detail now. So as you can see in the image in front of you, we have different types of approaches for having a score based feature importance method. So first thing is, if I have a complete data set, then obviously it will not only contain categorical columns, but it will also contain numerical columns. So finding the important features from the categorical columns will follow a different approach or a different score based statistical approach. And similarly for numerical, it will be different. So if we talk about the independent variables, which are categorical, but if the dependent variable or the target variable is also categorical, then the approaches that we use for feature importance is chi-square test and mutual information score. Similarly, if we have a categorical column as independent variable, while it is a regression problem, which means the y variable or the target variable is numerical, at that moment of time, we will be using ANOVA test or one kind of a correlation which is called as Kendall correlation. Now, if we come to the numerical columns, if I have categorical target variable, then again we will be using ANOVA test and Kendall correlation. And if we have a numerical column as independent variable, while the dependent variable is a numerical again, there we will be using Pearson correlation and Spearman correlation. Now, before moving on to the coding part, we will be looking at all these methods, a brief introduction about all these methods, what they exactly mean, and how they exactly work in a nutshell. And then we will be moving on to the actual coding on a data set using Python. So first, if we talk about chi-square test. So generally it is a measure whether two variables are coming from the same population or not. So if I have a population, so this is a population that I am having, and again I have a sample because obviously we will not be having the entire population with us. We will be training our model on a sample. So are we sure that this sample is coming from the same population? That is the thing, that is the major concept that we utilize when we talk about chi-square test. So now I have two categorical columns. I have, suppose, this column which is A, and I have another column which is B. So in our score based method, the first column will be our independent variable, the second column will be our dependent variable. Now we will also check whether B belongs to the same population or not. If A and B belongs to the same population, that means A and B have a lot of things similar, and that's why their chi-square score, which is p-value, will be on the lower side. And similarly, if they don't belong to the same population, if they belong to some other population, then their p-value will be very high, meaning that they are not at all similar. So generally, for all the tests, which is either it be chi-square test or the ANOVA test, the rule or the process is same. The first thing is we try to find out the f or sorry the chi uh, statistic value, for which we generally have the formula. Once we have the chi statistic value, we have a chi table, chi-square table, on which we check this chi statistic. And finally, based on the chi critical value, we get a p-value. So if we have a small reminder about statistics, especially about hypothesis testing, if we say that p-value is less than 0.05, then we accept the null hypothesis. keeping an assumption that our confidence is 95%. So similarly here also, if we have less p-value, that means they both belong to the same population. If they have high p-value, they will belong to the different population, and that's why they will be, they will not be that much similar, and hence any one of them will be having less feature importance. So what is the formula that we use to get this chi-statistic value? We have this formula where we get the observed value, we subtract the expected value, and then we divide it by the expected value. So in the statistical sessions that we will be taking, in that we will be discussing in detail how a chi-square test works on a different kinds of data, which is categorical columns coming from same or different population. But the theme will be different. But the theme will be the same. The process will exactly be the same. Similarly, if we move to the ANOVA test, here we try to find out whether the groups that we are having or the columns that we are having, whether these columns are same or different, which means whether the variance present or whether the mean of both the features are same or different. If we are able to find out that the mean is same, then both the columns are almost similar and the feature will be having higher score. If the mean is different, that means both the columns will not be similar and the importance will be lower, and hence the score will be lower. The process will again be same, wherein we will be finding the F statistic value, we will be going to the F table, and using the F critical value, I will be finding the final P value. And again, using the P value, I will try to find out which features are important and what features are not important. Again, in our statistical lectures, we will be talking in detail about how a specific ANOVA test, which are of different types. We have one-way ANOVA, two-way ANOVA, we have MANOVA tests. So all these things we will be discussing in our statistical lectures. But as of now, both the tests, which is chi-square test and ANOVA test, both are used to find out if the two features are same or not. So in chi-square test, whether both belongs to the same population or not. In ANOVA test, whether both are having the same mean or not. Now the next is mutual information score. Now if we take the two features and we try to find out what is the degree at which they both are related, then we are exactly talking about mutual information score, which is also called as information gain. So if we have multiple columns, suppose I take any two column again. So this is my x1 and I have my y. So if x1 is able to explain the values in y, so that means if by using x1, how much certain we are to get the value of y. So that is majorly uh, talked about in mutual information score, also called as information gain. Okay, so this is generally given by finding the entropy. So mutual information is equals to entropy of the feature minus the entropy of feature subset.